and cosine rules. So this is another little bit of trig that we're going to learn that's a bit different to the trig and the Pythag that you've already done. So I've written out the rules already. So if we look first at the sine rule, it's a over sine A, b over sine B equals c over sine C. Quite easy to remember, but what does it mean? So for both of these, we have little ABCs and big ABCs, so we're just going to find out what those are. So if I draw a triangle like this, these angles here are going to be the big ABCs, and then whichever one is opposite is going to be the little a. The line opposite the angle big C is little c, and then this one is little b. So that is what they are, and when we would use this is in the trig and Pythag you've done, they've all been right angled triangles, so the ones with this sign here. So Pythag for working out lengths and trig when you've got angles involved. And these ones, as you can see, they don't have to be right angled triangles, so this is why these ones are super useful. So we're going to go ahead and look at some examples of using the sine rule first. An important thing with the sine rule is, as you can see, there are two equals and you only ever have one equal sign in an equation. So you'd either be using that or that. It's kind of the same thing, just depends what you've labelled your triangle. So I'm just going to draw out our first example. Okay, so here we have our first example and we're looking for angles and we've been given lengths. So we know that we're going to be using the sine and cosine rules because it's not a right angle triangle. So that's the first thing we do. And now we're going to label some sides. So I'm going to call this one A. It really doesn't matter which one you call A, B or C. And then this is going to be little a. I'm going to call this one big B. This is going to be little c. We don't know these. Okay, because we've only got the A's and the B's, or you could have B's and C's or A's and C's, it's going to be the sine rule because the cosine rule involves all the little lengths, which we'll get to in a bit. So first of all, we're going to write this out. So we have A over sine A. So first step, label your triangle. Second step, formula. Let's substitute in. What do we know? We know little a, 6.7 over sine A. We know little b is 5.4, and we know big B is x. Oh, we know A, this is sine 95. Now we want to rearrange this because we're trying to find x. So first thing I'm going to do is pull x up, sine x up this side. So it's divide on this side, so it's going to be multiply on this side. And now the next step, which I'm going to write over here, is I'm going to try and get rid of this bit. So I'm going to pull the sine 95 up, and it's divide on this side, so it's multiply on this side. And then the 6.7 is multiply on this side, so it's going to be divide this side. So just rearranging. So we've got 5.4 multiplied by sine 95, and then divided by 6.7. Now to get the x, we've got a sine on this side kind of hugging it in the way. So to get rid of that, we do the inverse operation of sine, which is sine to the -1 of all of that. So I'm just going to put that on my calculator, find out what we get. The answer I get is x is 53.4 degrees to 1 decimal place. Don't forget the degrees. And just to note, this will be on likely to be on a calculator paper because of the shift signing. So that's an example of how we use it. Steps are label, and then 2 is formula, and then you just rearrange and solve. So let's look at another one, not too bad. Okay, so this is our next exam question, and we want to find x. So basically, first thing I'm going to do, following the steps, is label the diagram. In my head, I know it's going to be a sine or a cosine rule because it's a triangle involving angles and lengths, but it's not a right angle triangle, so it's not trig or Pythag. Okay, so first I'm going to call this one A. So this angle, the one opposite, is going to be big A. It's going to be little b. No, that's big B. That's going to be little b. This can be big C, and this can be C. So if I write on the formula, I want the x, the a value, so a over sine a equals, and then because I know little b and big B, whereas I don't know big C, I'm going to use the B. Okay, now I'm going to substitute what I know in, so I know little a is x, and then sine big A. We don't know big A yet. And little b is 12 over sine big B, 55. Okay, so what is big A? This is what we need, because we've got two unknowns in the equation, that's never going to work. So I know these two angles. I know the angles in a triangle in the interior add up to 180, and I've got two of them. So I know I can work out A. So A is 180 degrees minus this 20 degrees minus the 55 degrees. So A is equal to 105 degrees. Now I've found A to be 105 degrees, which I'm just going to write that. I can substitute that in. And then we've got all the information we need, we just need to rearrange and solve. So I want x on its own, this is annoying me, I want to bring that on this side, so I multiply x, let's divide on that side. So 12 multiplied by sine 105 divided by sine 55. I'm going to pop that in my calculator and see what the answer is. The answer I get for x is 14.2 to 1 decimal place. So we know that x is a length though, so I'm going to say don't forget your units. And hopefully you can see that means it isn't too bad, you just substitute into the formula. And we're going to go for a slightly harder one and then move on to the cosine rule. Okay, so this is our last example for sine rule. So we want to find x, so we're looking at this triangle here. We know that we're going to have to use the sine or cosine rule because it's not a right angled triangle. So let's label this up. We'll call that one A and we'll call this one big A. And just like the previous example we've done, we already know two of the angles, so we know we can work out A. So let's just do that. So angles add up to 180, so we've got 180 minus this one, 40 degrees, minus 65 degrees equals A. And that would make A 75 degrees. So I'm just going to rub that out and place that with 75 degrees. And that is big A. Then let's call this big B, and this one can be B, big C, and this one can be C. So the issue, let's just write out our formula. So we've labelled, now we're writing out a formula, and then we're going to substitute in what we know. So we know little a is x, and we know that sine big A is now sine 75. Now we're going to use b. So we don't know little b or little c, so which one am I going to go for? Well, I know I have the ability to work out little b because this is why it's giving me all this faffy information on the side. So I'm just going to call that b for now because we don't know it. And then sine b, the angle opposite is 40 degrees. Okay, so now what we need to do is we need to find b. So I'm just going to isolate this triangle bit here. Okay, so we're working with lengths and a right angled triangle. So we know we're working with Pythag. Length, right angled triangle, Pythag. Okay, so our Pythag formula is a squared plus b squared equals c squared, where c squared is the longest length, the hypotenuse. So let's label this up. For this one A, this is the b we're looking for, and then this is c. Substitute in our values. A squared is 5 squared plus b squared plus c squared, which is 13 squared. Rearrange 13 squared minus 5 squared because we want to get rid of that. So b equals the square root of 13 squared minus 5 squared. And if you put it on your calculator, you should get that b equals 12 centimetres. So we know this is 12 centimetres and we know this is 12 centimetres. So let's just continue subbing in. So we've got x equals sine 75 equals b, which we now know is 12 over sine 40. Rearrange this to find x, and we just get that. And this is divide on this side, so it's multiply on this side. And if you put that in the calculator, the answer you should get is x equals 18, and don't forget centimetres. So that's an example of sine, but with an extra step. So let's move on to the cosine rule. Okay, so as you can see, I've got the cosine rule written out here, which is a squared equals b squared plus c squared minus 2bc cos a. I've also got another formula written out here, which is the area of a triangle. So that is half ab sine c. So if we look back at our triangle, so this is, if you don't have a right angled triangle, this is the area, you can work it out. And basically what you have to have for this formula is you have to have an angle, and you have to know, so that would be C and then AB, and you have to have the two lengths between it. So to work out the area of a triangle, that when you don't have a right angle, you have to have an angle and the two lengths like hugging the angle. So let's have a look at examples of using the cosine rule and the area of a triangle. Okay, so here's our question. It's given us this triangle. I don't think it gave you that. And it's told you the area of the triangle is that, calculate the perimeter of a triangle. So in GCSE questions, they normally kind of give you step by step. So first of all, area of the triangle is that. So I'm looking at this triangle, it's given me the area, and I know it's not a right angled triangle, so I know that I'm going to use this formula. So area of a triangle is this. So area of a triangle is a half AB sine big C. Okay, and we know that is equal to 100. So if we label our triangle, we know that for the area you need an angle and the two lengths between it. So the angle we're looking for, the C here, is this one. And we can just call either one A, B. So let's go look at this. So a half, let's do times A times B, substituting those in, times sine, and then we're going to call it x now. So let's do this bit first before we rearrange. So we have 100 equals, and then half times 19.7 times 15.4 is 151.69 sine x. If I take this over this, I've got 100 divided by 151.69, which is 0.659, etc., equals sine x. Now leave that answer on your calculator if you're not going to do it in one step, because if you round it too early, it might affect your answer at the end, so that's always a good tip. Now we want x on its own, but we've got the sine in the way, so we need to do the inverse operation of sine, which is sine to the minus 1 of that. And that gives me an x value of 41.24, etc. So I'm just going to make a note of that on the side and on my diagram. Without simplifying it too much, because I'm going to use it in further calculations. So that was the first step. I've dealt with the area of the triangle bit, that's all I can do, and I've found an angle, which is going to be helpful. Now looking at the second part, calculate the perimeter of a triangle. So the perimeter is the length all the way along the outside. So I know that part, I know that part, but I don't know this part. So this part I'm going to label C. Okay, so I'm looking for an equation that involves ABC, and I know that's the cosine rule because it's not the sine rule, because you can only use like two of them at a time. So let me just write out the cosine rule. A squared equals b squared plus c squared minus 2bc cos A. Now this cos A, the only angle we know, because it's going to have to be that. So I'm going to rename that one, is going to be A. So that's going to become A, and then these are going to become B and C. Now it had to be the other way around for the first example, so just be aware that it can change. Maybe redraw the triangle out, I would, at each step. Okay, Let's just substitute everything in. So we're looking for a squared, we don't know a squared, well we're looking for a. B squared is 19.7 squared plus c squared, 15.4 squared minus 2 times b times c cos, and then the answer you got here, 41.24, etc. So just as a test of your calculator skills really, type that into your calculator. A is going to be the square root of all of that, so don't forget that. So I'll be back once I've typed this in. So hopefully if I've typed that in correctly and I have also done the square root step there, I should get an answer of about 13 metres, but not done. I'm asked to calculate the perimeter, so I need to add up the sides. So I've got this A, so perimeter is A plus B plus C. So I've got my A plus my B plus my C. Oh, I can't just write C down, can't put that in the calculator. So the answer should be 48.1 metres. Okay, and again, at every step when you use the calculator, please keep your previous answer in there, don't round it too soon. We're going to do one more cosine example. Okay, this is our final cosine example, but I've just given it away. So we're looking at this, angles and lengths. I want an angle, so I know I can't use trig or Pythag because it doesn't have a right angle. So firstly, I'm going to label the triangle. So I'm going to call this unknown angle A, and then I'm just going to call these B, C. It doesn't matter which way around. So I know it's not the sine rule because I'm using A, B and little c, and you can only use two at a time for that. So I know it's the cosine rule, so I'm going to write out the equation. A squared plus B squared minus 2bc cos A. Simple enough, just substitutes. The hardest thing is labelling the triangle really. So what is little a is 24 squared equals b squared is 21 squared plus 13 squared minus 2 times 21 times 13 cos A. Okay, so let's rearrange this. We've got 24 squared plus 21 on this side, so I'm going to subtract 21 on this side, plus 13 on this side, so I'm going to subtract 13 squared on this side. Then I'm going to leave that here. So all of these terms multiply together on this side, so I'm going to have to divide by them on this side. It's up to you at what point you start actually substituting stuff in. And then you've got cos A on this side, but you just want A, so you're going to have to do the inverse of cos, which is cos to the -1, or shift on your calculator. And all of this long, testing your calculator skills. So I'm going to substitute that in and then be back. Give me 5 hours. So, now I'm 100 years old, I have the answer 86.4 degrees to 1 decimal place.